So, first part, and there I would like to start with the history. So why was this entity created? Well, Chalmers as a university was rather early in discussing digital research infrastructure. In 2016, that is now 10 years ago, the Vice Rector for Research at Chalmers at that time initiated a group of researchers with some persons also from support functions like the IT office and other, the library and so on, because the Vice Rector of Research and others realized that what is now happening in research, and it has been happening for a while, is that digitalization changes the actual procedures, the modus operandi of research, how it is done. It's not only like you add something, you actually change the heart of research. And you see this in this list also. There are new research paradigms at the moment. AI is really the hot topic. Other topics will follow. That also comes from digital aspects. You get new types of results and resources. So research data is becoming important everywhere, especially in research infrastructures. So what was a classical research infrastructure today is becoming more and more a data infrastructure. You get models, AI models, you get software that is both a resource and a result from research, and so on. You can access both expertise and resources in new ways, and you get new opportunities for collaborating and sharing. And resources for collaborating and sharing, well, that sort of leads both to open science and to the discussion on security. Whom can you share with? Who should you share with? And who should you work with in the global setting? So Chalmers then realized that this landscape, that is the traditional support landscape at the university, with an IT office, with a library, with an archive, with a research support function in administration, it was not really suitable for this new type of digital research. Researchers did not know where to turn to, essentially, and they got sort of directed in circles in this landscape. So the hypothesis here was that, okay, if we want to build a successful university for the future, we need to have an integrated digital research infrastructure with sort of one way, one place where the researchers can access this and then get the help that they should have. It was also then said that, well, for classical research infrastructures like an accelerator or whatever you want to call it, what to talk about, this is usually owned by and sort of managed by research and researchers themselves. And to get really the anchoring in research, it's important that the ownership and responsibility also for digital research infrastructure is somehow anchored in the research system. So it is a matter for research, but it really needs collaboration and working together with IT office, library, etc. So that was the background of Chalmers e-Commons. This group thought about this for 4 years. I think it was good that it actually took 4 years because they were able to discuss things in depth. In 2019, the president of Chalmers decided that we should have this thing called Chalmers e-Commons. And then in 2020, you remember that that was the year of the pandemic, I was recruited as the director, so to build this organization. So now I've been there for 5 years. What do we have? Well, this is how we would like to be perceived by the researchers at Chalmers. So if you're a researcher or you're heading a research group or you are the head of a department at Chalmers or you're running another research infrastructure, then you should know that you can turn to us, Chalmers e-Commons, and we can try to help you directly. We have persons, I will come back to that, and we also have resources, but it's in our mandate that if we should not try to build everything ourselves. So if we see that there are suitable resources, either nationally or internationally, we should point to those. And it's actually an important part of what our task. So just to give an example, when it comes to high-performance computing, we have our own resources at Chalmers, but we see then if a researcher wants larger resources, we point actively to the national supercomputing infrastructure or EuroHPC, the European infrastructure. We have essentially three groups of people. So we have the persons and also then the resources for infrastructure, the actual infrastructure. So hardware and services on hardware. And that consists of the old supercomputing center at Chalmers. We inherited that. And also the research support function at the IT office. So that's part of what we have then within Chalmers e-Commons. We have on the right-hand side something that was essentially created when Chalmers e-Commons was started, the Chalmers data office. And that gives support for the full data lifecycle. So starting from planning for research data with research data management plans and connections to, okay, how much storage do I need and so on. All the way through actively working with data, analysis of data, large-scale analysis also perhaps, to preserving and archiving this data in the end and possibly publishing it. So if there is a need for publishing data, that is also in our mandate. In the middle, we have research engineers. We call them digital research engineers. They are a main connection point to research. They work with different topics, and they also have different areas of responsibility. They can participate in research projects like an active partner for, say, like 6 months on a half-time basis. But then it's not like for another postdoc. It's like contributing with their specific competence for example, for starting up the use of machine learning in a research project. Not continuing, but providing a little bit of startup competence and material. In the group, which is currently about 18 persons, we are recruiting a couple of persons also. So about 18 persons sitting together in a corridor at the physics building at Chalmers. So that gives a little bit of concrete anchoring of this. In the group, we have research engineers then that work or have competence in AI machine learning, of course, high-performance computing, and research data management. And you see, it's not a lot of people in each one of these topics, but at least there is one. So AI machine learning, I think at the moment we have 5 persons working in that area. A couple of them are shared with high-performance computing. So they have the experience of using large-scale models on large-scale computers. And then we have these green topics. That's modules where we, as Chalmers e-Commons, host national or international, or nodes in national or international collaborations. So we have a national infrastructure for visualization, scientific visualization, and then we have Chalmers node for that. So it's 2 persons that work on a national basis, sit in our work environment and contribute with their expertise in visualization. We have 2 persons working with building the infrastructure, the e-infrastructure for Sweden in the square kilometer array project, which is a huge global project in radio astronomy. And Sweden has a small part of that, so we need to build our infrastructure, and that is then done by 2 persons sitting at Chalmers e-Commons in collaboration with the Uppsala Space Observatory, that is also part of Chalmers. And finally, we have 3 persons working in a big national effort on life sciences, SciLife Lab, where there is a large part of this working with data-driven life science. And there's a need to build services and operate services, and we have 3 persons then working in that environment too. So of these 18 persons, more than 7, I will come back to that, are actually engaged in national collaborations and international collaborations, mostly national, but they are working in those environments. Okay? So what is the key characteristics here? Well, we are a research infrastructure for all research at Chalmers. So we don't have a specific field that we are focusing on. If Chalmers president says that, well, this is a strategically important area, you need to put resources here, then we can do that, of course, but it's not our decision. It's coming from president. We are part of the, well, I'll come back to that. Okay. We are, and that's also in our mandate, it's clear that we are not only providing services and resources, the focus is really on expertise. So both these research engineers and also the technical staff connected to the large-scale computing, they interact a lot with researchers on a daily basis and sometimes work more deeply with them in projects also. We have in our mandate, as I said, to be the gateway to well, local efforts like the grants office. That's not part of Chalmers e-commerce, but we interact with them. But also the national and international resources and expertise. So it's really written down that this is what you should do. We work extensively close to the IT office, that's ITA here, a library, archive, and so on, and we build bridges between these functions and research activities also. So if you go to the library, for example, where they interact with researchers in some cases, but maybe not in the area of research data in the way that they are usually doing or should be doing. So then we are a bridge. I can say that the governance here in my operational management group, I have 1 person employed at the IT office and 1 person employed at the library that sits in my operational management group and are actually then paid from Chalmers e-commons and working for Chalmers e-commons in those functions. And where this comes from is that Chalmers has a set-up scheme for research infrastructures. So it's clear from this setup what is a Chalmers research infrastructure. It has a host department, for example. Our host department is physics. It's governed in a specific way, so it has a separate budget and a separate board. It interacts with Chalmers management in a specific way, so we report in a yearly wheel. It's also clear that the underlying business model is clear from this definition of a Chalmers research infrastructure. So we get a grant centrally from Chalmers, grant from the president. That's a base level grant. So we can provide base level resources and base level expertise. But after that, researchers need to contribute with funding from, well, either their own department or from a research grant. So that is sort of predefined how this will work. And it's also predefined, for example, that all researchers at Chalmers should have equal access to the resources, either by accessing this free at the point of use base level or by paying in. Actually, what I did, I included the full mandate in these slides, mostly for reference, because I heard from Erika that the plan is to make the slides available afterwards. So I will probably not go into the details here, but I will skip through 3 slides where the full mandate is. So this is the decision by the president from 2020. And the thing that I would like to stress here maybe on this page is that, well, it's, of course, e-commerce should provide support for the highest research quality and be driven by the needs of research. It's sort of obvious. But this should be done based on a data-centric workflow. So this was then realized in this group working before e-commons. So it's sort of set up a data life cycle here where we should work with all the parts. And that includes computation and analysis. So that's where the high-performance computing comes in then. Yeah, I will not go into the details. I will just show that picture that is also in the mandate. It's somewhat similar to the picture of e-commons that I showed earlier. So researchers, institutioner, forskargrupper, centra, etc. in Swedish, they should turn to e-commons and then we can direct them to different other types of expertise at the university. And finally, one maybe important point here when you dig down into the details that has been part of the success, whatever you want to call it, of the organization. We lead the work of persons. We at Chalmers e-commons lead the work of persons doing research support at the IT office and the library and perhaps other places also in the future. So they are employed formally in that organization, but they are paid for by us and we are the work-leading entity. And that I think is pretty unique, that a research organization like we are leading the work of support functions. And this is tricky. This is really tricky, and we haven't really succeeded with everything, but it's a good thing. So that was like the overall. I will try to go a little bit in detail, maybe focusing on a few things. So Chalmers Data Office, as I said, we support all phases of the research data lifecycle. And here I could perhaps mention, to be a little bit more concrete also, it's about 4 persons here. So it's not a huge entity. Most of these persons are employed at the library, but we have one full-time research data steward, whatever you want to call it, at Chalmers e-commons employed by us also. But they work as a team. We currently have a project ongoing to implement the full workflow for research data, going from working with active data, for example, on the large-scale computers, all the way to the archive. And I'll come back to that in a second. And something that I think we are pretty advanced on is trying to use research data management plans not as an administrative burden on researchers, but an actual tool for planning the research for researchers and also for helping Chalmers. So we have now been working with the Data Stewardship Wizard tool for some time in collaboration with the developers of this tool also to make sure that it's integrated in the sort of support functions at Chalmers University. So I can give a concrete example. When a researcher today gets a grant from the Swedish Research Council, the head of department has to sign the agreement, and in that it says that there should be a research data management plan. That's a requirement from the funder. Then what we do is that we collect information on these grants and we send out an invitation to the researchers that have got the grants. This is sort of an automatic procedure. Okay, well, congratulations. We have here a link to a pre-filled or partly pre-filled research data management plan where the title and all researchers involved and so on are included. Please use this. And when the researcher then fills this in, he or she might, for example, tick the box, I'm going to deal with personal data. And then there is a message going to the data protection officer at Chalmers saying, here a project that is going to deal with personal data is starting. And here is their research data management plan. If you want to talk to them, get in contact. So this we're building on all the time. We will also try, this is not ongoing, if a researcher says that I need to store 500 terabytes of film or digital film, well, there will be a message going to the IT office and us at Ecom and say, okay, here comes someone that has a large storage need. So we're trying to build this automatically. And I think it's appreciated, actually. We see now a lot of researchers using the tool. Yeah, and on the other hand, I should also mention this, on the publication end, we work closely with the Swedish National Data Service and their new portal, researchdata.se. So if a researcher, the goal is that if a researcher wants to publish data that is now being made fair, been made well documented, there should just be a push of a button to make it appear on researchdata.se. We are not there yet, but we are working on that. Finally, we proposed guidelines for good research data management, and that was then decided by the President in 2023. And I thought I'd do these guidelines are pretty short. It's not like a 5-page document. This is the essential part of the guidelines. So all research activities at Chalmers should have a research data management plan. It's not at all implemented yet, but I mean, it's a decision by the President, so it's more than a recommendation. Decisions on how to use research data, and it should be retained at Chalmers, and if it is possible for us to store it, we should do it. So we should keep control of the data. It's not always possible, but if it is, we should. And then the final part, all data that's important for long-term documentation of research results, it should be as fair as possible, so that it's actually possible to reuse them in some way. And this has to do with the reproducibility of research and all aspects of research quality. And it seems pretty obvious in a sense, but in practice it's not often not done, I would say. Okay. It's actually part of Swedish law also. So if a university presents results, research results, it's part of the law that the documentation for those research results should be preserved and actually also, in a sense, be made publicly open, because we have the law of access to public information. So anyone can ask for the results. There will be a security check, but anyone can ask. So I have been focusing a bit now on the data side, and I will finish that by presenting that picture. This is how we now are building the data system at Chalmers. So we have active data on the left-hand side, where we are building, setting up resources for sharing data in active projects, but we are not really there yet. So we are looking at Nextcloud, for example, but then it has to be adopted to Chalmers. We are buying in from Gothenburg University a trusted research environment that we can use for secret data or sensitive personal data. It functions like a vault, so you can check in data and then you work and then you can check out results. But essentially, this is the easy part. Here, well, the responsibility of the data really lies with research and the research departments and the researchers themselves. It's provided following this basic business model. If you go to the right-hand part, there comes the responsibility of Chalmers as a university in the Swedish setting in. So their responsibility of data that needs to be preserved, it has to lie with Chalmers as a university. Because researchers might move, departments might close down, and so on. So essentially, there's no one to send the bill to, or there might not be anyone to send the bill to. So Chalmers needs to take this, and also by law then, as I said, Chalmers needs to take that. Of course, research then feels that this is a free resource, someone else is paying, which is not true, of course, but there is a risk here that research dumps data in this long-term preservation setting. So then it's important to really only preserve the data that is needed to document the research, for example, to reproduce the results of a paper, and also that you can actually do it, so that it's well documented, fair. So then we have this, or we are building this oval in the middle, which is part of Chalmers data office, people helping researchers selecting what should be preserved, what should not be preserved. Okay, a little bit about the other parts of e-commons. So when it comes to e-infrastructure, well, we support researchers with this. It's both within e-commons, where we have the high-performance computers, and it's then in the connection to the IT office, where they, for example, can provide a server with a web service that makes a database available. And it's the same business model at both places. We have our own local general purpose medium-size high-performance computer. It's called Vera. It will remain Vera by name, but we constantly renew it. So there's a specific part of our grant from the president that is long-term and used then for renewing this local resource. So renewing, running operational costs, paying the electricity bill, and paying the staff that operates it. And that, of course, is then made accessible within Chalmers. We also today operate a large-scale computer, a national large-scale computer, which is specifically designed for AI and machine learning. Alvis is the name. But then that is then accessible on the national level through the national NICE infrastructure, National Infrastructure for Supercomputing. So next slide. Well, just to show you what this is, it's a fairly large computer, 12,000 cores, almost 1,000 GPUs, and 9 petabytes of storage. It is currently within the NICE system. From 1st of July next year, it will not be, so then it will be Chalmers resource. So then we will have to figure out how to use this, and also how to pay for it. So the electricity bill and facility bill for this is about 3 million Swedish kronor per year. Finally, these digital research experts in e-commons, well, they work on support in different ways, but they do work then, as I said, in more in-depth collaborations with research projects, and those are selected in a sort of a competitive process. We ask for expression of interest, and e-commons board selects. So the main idea there is to get things going, mainly then in the area of AI machine learning used in research projects. And there we collaborate also with the research center, that is the Chalmers AI Research Center. That was a big effort, started 10 years ago almost at Chalmers. And actually I talked about the data-driven life science effort. I talked about the InfraVis effort, where we are nodes in national collaborations. I should also mention that we, from this year, have we organize a regular PhD level course. It's a small course that is given to all, or offered to all PhD students at Chalmers, where we introduce digital resources in research. So we pick the topics that we have within the Chalmers e-commons, but we also look in the whole world, so to say. So we point to S&D and NICE and EuroHPC and so on. So, well, introducing the Swedish landscape of digital research infrastructures, and this is at least partly something that I think several of you have heard about and maybe seen before. So, essentially there are 3 existing entities and 1 emerging entity. So we have S&D, the Swedish National Data Service. We have NICE, that is the National Academic Infrastructure for Supercomputing. We have SUNET, that has the task to operate and run the connectivity, but also does other things. And then we have this UNIDIG that Well, it's so new, so it didn't have a logo, so I had to write it there. But I'll come back to that. I'll say a few words about each one of these, because it also sets the scene for how we can collaborate with Europe. So I think it is a realization now in Sweden that a Swedish university by itself is normally not able to work with a European setting on its own, or it will come into competition with other Swedish universities. And even though Sweden is a country larger than Iceland, we see that it's a rather small country in Europe. So if Germany says something, that will probably happen, but if Sweden says something, we need to pull up with some other countries. S&D helps researchers, and their task is to make all types of digital data findable and accessible, or at least you should know how to access it. So S&D provides resources, a catalog, researchdata.se, for Swedish research data. It provides help for describing, publishing, and sharing this data, and also for managing data sort of efficiently within the research process. And we then, at the Chalmers Data Office, Chalmers eCommons, we collaborate very closely with S&D. Because what S&D, they have an office with like, I think it's about 15 persons, and they also have a big national networks. They have communities for discussions, etc. That helps us a lot. And as I said, we work with them for the publication setting. I wrote here the coffee project. That is ongoing today within S&D, where we do, or together with them, we do deep interviews with researchers to find out, deep structured interviews, to find out what are really their needs, what capabilities are they in need of in their research, what digital capabilities. I will put a link to that in this material later, because I think it's actually a very important and good project, because few research infrastructures, digital research infrastructures really dig down into the needs. That's rare. And now S&D, together with universities, is trying to do this. S&D as a structure is hosted by University of Gothenburg. It is funded by the Swedish Research Council through grants and 9 consortium universities. And here comes a little bit of your question also. It's grant-based, at the moment at least. So S&D has to reapply every 3rd year to get a new grant to operate the infrastructure. 3. And it is changing, and I'll come to that. S&D, I think what one can say, has the broadest network among all Swedish research institutions. So we have 38 universities and högskolor in Sweden. There are a few more included than S&D. So they really sort of reach out to all parts of Swedish research and academic institutions. So it's essentially a consortium as it functions, but it's funded through the Swedish Research Council mainly by grants. NICE is by far, I would say, the largest entity in this setting. It's the high-performance computing infrastructure. And it maintains and builds then large-scale computing resources, including resources for artificial intelligence, and today also wants to provide data services, so like storage of data for a fee. And what is happening there, the previous situations maybe not so interesting, but what is happening is that the resources will be centralized at Linköping University. Again, that the actual computers are there are not so important, not even for Linköping University, but the competence and the ownership is important for them. And there is then a Euro-HPC system, a mid-range Euro-HPC system, Arrhenius, it's about to be delivered, and it will be operational in first half of 2026. And Linköping and NICE will also host the resources, the computer, for the Swedish AI factory called Mimer that was also granted by the EUR-HPC joint undertaking recently. But there the actual persons, and I think that's the most important part of AI factory, they will be set up in collaboration between NICE and the Research Institutes of Sweden, RISE, which is another type of entity. It's not a university. Here also the Swedish Innovation Agency is involved, Vinnova. So the staff for Mimer, research engineers helping both researchers and companies using that resource, will be at several locations in Sweden, including Chalmers and Chalmers e-commons. So we will have 2 persons working in the Mimer setting. Okay, again going back to the funding streams, NICE is hosted by Linköping University only, so it's not a consortium. It's funded by Swedish Research Council with grants at the moment in quotation marks, because this effort is so big, so it needs to be funded continuously. I mean, it's seen at the ministry level that we need to provide some sustainability here. Formally, it's grants. We also provide some user support at, for example, Chalmers e-commons. So for Arrhenius, we will have persons, research engineers, that will then move their focus from our local Alvis computer to the Arrhenius computer at Linköping. SUNET is a little bit an odd bird in this system, not by what it provides. It provides connectivity and it provides also other types of services for research and education, digital services. But what is odd is that it is part of the Swedish Research Council. So the Swedish Research Council is both a funder of digital research infrastructure, S&D and NICE, and a provider of research infrastructure, digital research infrastructure. And this is an odd creation. I personally tend to criticize it because it's difficult to sit on these 2 chairs. And it also has a different type of funding scheme. So there is a separate part of the Research Council funding that comes from the government allocated for SUNET. So it's a government decision every year to fund SUNET. And then up till a few weeks ago, that was it. Now Swedish universities, through the Swedish Rectors Conference, SUHF, have taken an action and created a consortium of, I think, 38. I have not seen all the signatures, but I think all 38 universities in Sweden, to build a collaboration, a collaborative effort for digital infrastructure for Swedish higher education. And the focus there in the beginning will be on education, resources needed for education, and resources needed for administration. But I was at a meeting, a high-level meeting last week, where the head of this, the rector of Stockholm University, was quite clear that, well, resources are also needed for research. So it is clear that UNIDIG, as the name is, will look into that area also. Maybe not now, but in the future. So, to be frank, this is becoming a bit of a mess. So there has been a long process in Sweden arguing for better integration of national digital research infrastructure, like Chalmers e-commons, for putting this together. But as has been said already then, and also following your remark, there are different governance structures, funding models, and relations to the universities for S&D, NICE, and SUNET. And now UNIDIG adds to that with a 4th creation. So these entities today, they have different perspectives, they have partly overlapping activities, and actually also some, well, it's difficult to get this to work. To add to this, there is a proposal from the Swedish Research Council that maybe S&D should be moved into Swedish Research Council to form an integrated entity there together with SUNET, while NICE should remain at Linköping. And adding to this, then we have UNIDIG. So it's a bit of a mess. It is good that the Director General of the Swedish Research Council sits together with the head of UNIDIG, and they agree on that we need to work together to make this function. That is good, but that happened only last week. So we'll see where this moves. And why do I want to talk about this? Well, this also gives the setting for working with Europe. So in some cases, it is very clear who in this landscape should take the initiative towards Europe. In other cases, it's not so clear. So for EuroHPC and AI factories, it's pretty clear. It's nice. So the Swedish Research Council is indeed representing Sweden in the governing board of EuroHPC, but the actual actor and the real work is done by NICE and Linköping University. And they have close connections to Research Council and also to the ministry. So this works fine. It's not so clear when it comes to European Open Science Cloud. So there may be a few words about what is happening there. So for a long time, and now I'm pretty open here, it was unclear what this initiative would deliver, or if it would deliver something that could be used in real research. It's now 10 years, I would say, since this was started. But recently, we can see real results, real concrete results and services that are emerging. And it might still be a long way to go to this vision, connected, interoperable, and reusable ecosystems of research data and related services. But there are now national and thematic nodes that actually provide something, services and resources. They are emerging. So nationally, for example, Finland and the Netherlands and Poland have these national nodes now. And if you look at the thematic nodes, well, biobanking and biotechnology or biomolecular technology, represented by BBMRI, that's an ERIC, and it's also an S3 project. And they are now also then hosting a node in EOSC. PANOSC collaboration on research data between synchrotrons and light sources in general, also a node in EOSC. CERN, high energy physics, hosts a node in EOSC. And new nodes will be added, and then they will be connected according to a set rules. So it's getting there. How will EOSC then develop beyond 2027? Well, for the new framework program in Europe, that is still being discussed, and it's important. How will it be governed? How will it be funded? What is clear is that the Commission, at least informally, they suggest a joint undertaking like EuroHPC, which put a lot of governance and a lot of steering in the central organization. It's also clear that they will require funding, co-funding for this in real money from the member states, like in EuroHPC. So that on EOSC. How can we work from the Swedish setting then in EOSC? Well, we are now 9 universities participating in the EOSC Association. So the EOSC Association is an entity set up to provide the input from the actual researchers and users of EOSC, potential users then in the future. Swedish Research Council, SRC, is a mandated organization, so they really have a task to coordinate this in the best possible way. And also ESS, a Swedish large-scale research infrastructure for spallation source. It's also an S3 project. They are an entity by themselves. It's a limited company, so they are also eligible for taking a stand, of being part of the association. So that's the current situation. In practice, the Swedish Research Council actually sits on 3 chairs here, so they also represent Sweden, the government, in the steering board. So they represent the government, they fund research, and they also provide resources to SUNET. And it has been difficult to coordinate how should we as Sweden work towards EOSC. It's probably not possible for us as individual universities to really take on the national work. We can participate in projects supported by grants from the Commission, but that is not what EOSC is meant to be. It's meant to be a sustainable organization or infrastructure that will remain. The Swedish National Data Service, S&D, they submitted a proposal that was not supported as to be a node, to be a national node. That was not supported at the European level, mainly because they didn't have the underlying actual resources. So storing data, etc. That is done by the universities or SUNET. Now it's a discussion then on Swedish Research Council to submit a new proposal in the upcoming round, and the collaboration is getting better, but still there is a way, quite a long way to go, I would say. And I will be, we'll see how it goes. So question is, okay, now we have research security emerging as a topic that is discussed everywhere, and especially at the political level, I would say, but also at the leaderships of universities. And then suddenly open science, it seems like we should stop talking about open science. So that's a question. Maybe we should, just to provoke you a little bit more, but not then because of this research security topic emerging. And I will argue a bit about this, and maybe this will come back in the panel discussion also later. Actually, I don't think we should talk about research security either. But I would like to argue for focusing on, okay, what is really the purpose of research? So it can become a philosophical discussion. Why are universities here? What is universities providing to society, etc. But it's probably good to go back to why should we do research? Well, we should advance knowledge and provide new knowledge so that we can develop society in good ways. And sometimes this knowledge is used in bad ways also. But that is happening. You can discuss the ethics of the Manhattan Project, for example. That was really a research project. And then, okay, what is needed for rapid progress of high-quality research or excellent research, whatever that means? Today, going back to my original slide, actually, we see that digitalization and digital resources for helping research, it's really becoming a core thing. So digital research support for making research possible in a rapid way, in a high-quality way, is important. I think that is pretty clear. It's a core activity within research, like any other research infrastructure, or even the functionality of the publishing system or whatever. Today, then, we see that there are issues of, let's call it security or governance of these digital aspects. It's emerging. So data security, information security, all of that is emerging. But it's actually not new. Discussing how to present, how to distribute, how to share research knowledge, research results, etc. It has been there all the way since research started. What is new is that it has changed because of digitalization. So it might be good to go back to these basics and then to start to think about how can now these digital aspects and what is needed for research quality, how can it be related to, for example, geopolitics? So should we work with researchers from China? Should we share data openly on specific fields that might be of importance for security in some way, or just for making further research progress? that's where we need to relate these aspects, I think. There's a danger of focusing on short terms like open science and research security, because it means different things for different people. So open science, when you talk to some persons, it means, okay, we should provide all information about all research projects as soon as possible in the research projects. That's a sort of fundamental stand for open science. It can also mean, like what is stated in a sentence, as open as possible, as restricted as necessary. Okay, a little bit better, but what is as restricted as necessary? What does that mean? For a researcher, it could mean that, well, I need to restrict the access to this data because I have to keep it to myself to be able to write more Nature papers. While for a policy body, it could mean that, okay, everything that can be provided openly without risking personal information, industry secrets, etc., should be presented up openly. So these are quite different interpretations also of as restricted as possible. The same with research security. For some persons it means IT security. For others it means security of data. For a third person it means, well, I should not work with a researcher from China, and so on. So a little bit more details in the discussion are probably needed. That's why I think we should not only use these terms. So I hope that the discussion both at the political level, at the university management level, and among researchers can get into the nuances of these topics. I think that is important. I think I'll stop there. Thank you very much.
Okay, hello everybody. My name is Guðmundur Kennesti, and I'm going to talk to you today about yfir. With me is Elvar Jónsson. He's part of our yfir team. Like the slide says, yfir stands for Icelandic Research E-Infrastructure. yfir was created really by the IT department. It was solely our initiative. What we saw back in time was that we realized there was a lack of services from the IT department. The IT department in this university has done a lot. If you think about IT and educational services, but in the other side of the university, the research and science part, there was a lack of services. So, and at that time, we were lucky enough that Rafrænir, they decided to open up a roadmap, and we were crazy enough to apply for it, and they were crazy enough to let us in to the roadmap. So we were quite lucky, and we since then we have done a lot of things. The yfir project, it started in 2021. The objectives was to develop a powerful infrastructure to support and service research in Iceland. So at that time, we decided, okay, this should not only be for our university, this should be like a national service. The IT department was then and still is. We provide a lot of services to other universities. For example, we offer student management services, system services. So, and these services included with the infrastructure should be regarding IT consultancy, HPC, storage of data, and sharing of data. So since then, we have been granted a lot of funds, about 500 million Icelandic kroners. And if I recall correctly, that is about 3.4 million euros. Yeah, I think so. And we have been operational since 2022, and of course we are still expanding the infrastructure, and we'll talk about that later. And further construction is ongoing. Regarding usage, we actually are experiencing a lot of growth in terms of usage, which we'll also go into. I'm so proud of my ERA team, which is with us here today. When we started, we didn't have such a team, but today we have it, and I'm so proud of it, and I think we are doing great things. Current ERA services, it's about like consultancy, like I said, where we can come in and talk with scientists and understand the needs and provide them just general consultancy. We can help them solving problems which they run into. We can implement solutions, and we can compile software, and we can assist with purchasing of solutions. We have a data storage, which is a safe and efficient storage of research data. We think today that we can accept sensitive data, personal data, and all of this is inside the umbrella of the university certification of ISO 27001, which is about information security. We are providing solutions for data sharing, and we have a lot of computing power. So where we are at the moment, the data storage is up and running. We invested in a solution like called NetApp, which acts as a data broker where we can integrate various data storages and into one data cloud in a way. We have currently about 4 petabytes, and the solution works in a smart way, so we can move data to places where it's more economical to store them. And the data cloud is currently connected where the scientists calculate things, the HPC. And the HPC today is about 800 teraflops. Yes, data sharing cloud is using Nextcloud. User support is available. So I would like to ask Elvar to go into more detail, and then I will come back in the end.
Right, so the first need that ERA addressed was to build up a high-performance computing center, which today consists of about just under 10,000 cores. We have a very modest amount of GPU cards. It is a need which is we recognize is becoming more and more, so that's something we would like to increase in the future. We are currently at these 800 teraflops, but thanks to a recently funded project, the AI Factory Antenna Iceland, we are going to finally break the petaflop mark. Now this system is split into 2 high-performance computing clusters, but what brings them both together is this NetApp storage cloud or system, which connects all the computers together and also connects us to the scientists. But this is it's a smart storage system which recognizes if data is being processed and then feeds it into what we call hot storage, and it also recognizes if the data is not being touched and moves it to a cold storage. So it's a tiered storage system. Regarding these services, then we do provide this IT consultancy for researchers and their projects. It doesn't mean that you just send us an email and you get some answer. It means also that we go out into the field, we meet with researchers and their groups at their location, in their labs, and we sit down and we discuss and we try to figure out solutions together if we can adopt our system to their needs. And we recently also provide access to a cloud which allows for collaborative data sharing, so not just within Iceland, but also with research groups abroad. Now, if you want more information, you can go to our newly launched yfir homepage, or if you have any questions or you want some user support, you can contact us directly. This is yfir.is and yfir@hi.is. Now, since launch, we have seen an almost linear increase in the terms of number of registered users for the high-performance computing. So it has grown almost by 100 active users every year since 2022. And given these data points, it seems like there is no end in sight of this growth. And then very recently, we had this, we launched this yfir Cloud, a cloud service, and there you can see this jump of additional 100 users just for the cloud solution. Yearly, we see a roughly 30 to 40% increase in the use of the HPC system. And so a fun statistic is that just last year, we ran at almost 80% theoretical capacity, meaning that 24/7, 365 days of the year, 80% of the system was being used for computation. What has also been a significant increase is the request for data storage, sharing, and also management solution. And there are three main projects which we have been running to try to address this need. One was the launching of the Nextcloud, the cloud solution, which really helps researchers collaborate and work together, as well as have a good place for the data where it can be accessed anywhere in the world. Two is to try to work more closely with and collaborate with the Icelandic gagnis, which is a platform to expose your published data or research data. And then a larger project which just has to do with research data management in general, something where a project which requires dedicated personnel from our side, working with the researchers from day one as they launch the research project in order to manage and plan into the future how to manage their data. And there on the right, you can see there has also been this very linear increase in the requests and usage of our storage space. So there is certainly need for more space for data in Iceland. Now, as an example of our involvement, we are active partners in a consortium project called IceLink, which brings together groups from Iceland, Denmark, Greenland, Belgium, and Spain. It's about gathering in situ data regarding land ice in the North Atlantic Ocean or in the North Atlantic. And our involvement is to be data managers and planners where we try to connect the various research groups at a given date in order to share or transfer data between groups so they can be processed from measurements down to results, down to feeding them into climate-based models so that we can predict how land ice in the North Atlantic is going to develop into the future. And so working on such a project, there are some questions which obviously arise. And for example, how and where do we store raw data and derivative data? And how do we enforce and facilitate creation of metadata so that this data can be easily reused at some later point in time? And then maybe the more sensitive one, how do we secure long-term storage of what's called time-sensitive data? So these are measurements which may never be able to recreate, because this is sort of like data which is telling the history of how this land ice is evolving as climate change becomes a more serious problem. But through a project like this, we are trying to learn how to do research data management so we can bring it down to the smaller level, and how can we apply it to just research groups in Iceland. We have launched the yfir Data Cloud. It's based on the Nextcloud solution. It is directly connected to that NetApp storage grid. So there's a direct connection also to the HPC system. So this can be then not just a place for raw data for analysis. It can also be a place for just sharing data between different researchers. It's very easy to use, very user-friendly in the sense that if researchers are accustomed to working with what's called Dropbox, it just looks like a Dropbox with the University of Iceland logo. But it has a lot of nice features such as, well, it can also automate the creation of metadata. So as you upload your data to your storage space, metadata can be automatically created. There are also very many other features which can be included, such as video and text chats, editors, and so on and so on. So one could envision that this could replace Dropbox, Google Drive, Zoom, etc. Just have all of these services in one place. Gagnis, I mentioned as a very nice service developed here in Iceland as a repository for published data. And this is something that we would like to collaborate more with in the future, but at the very least, we would like to act as mediators between researchers who are using our services, and when it comes to publishing data, we point them towards Gagnis. Other service that we have started to provide, that is to make researchers' stories and research successes more visible by publishing some of their results on our webpage. There to highlight just the collaboration between us and them and how they are using our services to accomplish this research. And we have also started to collect just publications per year which have used our services, which is something we expect to grow quite a bit more in the coming years. Yes, so that's my piece.
Okay. So a little bit then about what we are doing right now and in the coming months. This is really what you see on the screen, our new concept model. So it's about the two main components, scientific computing, which is really like HPC, and research data management. And then we have security, we have a network, and software development, science software offering, which is really about helping scientists to find the right software for their needs. IT training for scientists and IT consulting. So but I would like to dive more into the research data management service, which we are now working on. In our latest grant, we got some funds to work with Landsspítali, where we are trying to make research data more accessible for researchers in health science. And it is also a question of how can we store good health research data. It was like that some time ago, that when a health science research project ended, then the scientists needed to delete the data, but now, according to our law, they can store it, and we need to have a special solution for that. And we are working with Landsspítali in that. But what we are also doing is that we want to create what I saw Chalmers has, like a data service, where we can work with the scientists from the start, where we can come in and help them with the data management plan. We can help them build up the IT environment for the research project, and we can assist them during the project life cycle. And then at the end, we can help them with making the data, research data, open and available as it can be. So that is really what we are working on. But scientific computing is an important part, and we are always investing in hardware for that. Security, like Elvar has been talking about, then what is happening is that we are getting more and more research data at one place. So protecting that one place becomes very important. So that's why we have put a lot of effort into security. Software development, I would like to end with this slide, because this is an active project which we are working on right now with both the Landspítali and the health science here in our university, where we are creating a solution for pseudo-neminization. I can never pronounce this. It's a terrible English word. Which in Icelandic we simply call nafnblindakerfi. And what we are doing there is we are creating a solution where we have this situation. You have a scientist who's working with sensitive personal data. And he doesn't want to work with sensitive personal data, but he wants to work with the data. So how can we code the data so he can relax? He is not working with personal information. So we have programmed a solution for that, and we are working on that. When you have such a solution, then of course security becomes a big issue, and we have a high focus on that. So that's just an example of what we are doing now in creating solutions for our scientists. So that was IRI in a nutshell, in a very fast time. I hope you got a good overview. Thank you.
My name is Guðbjörg Andrea Jónsdóttir, and I'm a senior advisor at the Ministry of Culture, Innovation and Higher Education. But I worked here at the university for 20 years, so I feel at home when I'm here. But today I'm going to talk shortly about the government's 10-year vision for science, technology and innovation, with a special focus on open and fair data. The strategy on science, technological development and innovation until 2035 was adopted by the government in June this year, and it underpins how we want Iceland's research and innovation system to develop by 2035. I'll begin by setting the big picture of the policy, and then I'll try to zoom in on open and responsible science and the FAIR principles a little bit. The core idea of the vision until 2035 is that science and innovation are the engines of prosperity and quality of life. The vision also recognizes that science is essential for sustainability and environmental protection. This is not just about more research, it's about better use of knowledge across government, business, and society. Open science, including open and fair data, is one of the tools to make the vision real and impactful. The key priorities of the vision is that by 2035, we want to have a diverse and collaborative research and innovation ecosystem that tackles social challenges. And the goal is very ambitious. It's to invest 3.5% of GDP in research and development, with strong cooperation between the universities, industry, and government. I know this is less than Sweden is doing already, but still it's quite a big jump for us because we are starting now at around 2.62% of GDP. So it is quite a long way to go. And of course, we need some actions in order to make this happen. But we want Iceland's knowledge-based innovation system to support both basic and applied research and to tap into global expertise. Education is an essential part of the policy. It is really the foundation of all. And we want to see an inclusive system that nurtures curiosity and creativity and supports sustainability, equality, and quality of life. The policy rests on these three main pillars. First, we see strong human resources, and there is a focus there on attracting, developing, and retaining talented researchers, innovators, and students. Secondly, we have the pillar that is robust infrastructure and cooperation, the technology and digital tools, and the networks needed to do cutting-edge research. And last but not least, the third pillar is about reliable long-term funding. mainly so that institutions and researchers can plan ahead and take on ambitious long-term projects. And I just want to give you sort of a glimpse into the policy a little bit more, especially one of the main sort of goals of robust infrastructure and collaboration. It is to strengthen infrastructure and collaboration, and for that we need to have modern shared research environments from labs to data infrastructures. And these infrastructures should support cross-disciplinary work so researchers are not stuck within narrow silos. We want the infrastructures that cross institutional and scientific boundaries, encouraging cooperation between universities, institutes, hospitals, government, and industry. Fair and open data practices are a key part of this development. They make it easier to share and combine knowledge. And then we come to the open and responsible science. The government has put a clear emphasis on open and responsible science, and these two ideas must go together. Open science is about making publications, data, and methods as open as possible and as closed as necessary, as Sverker already said, so that others can reuse and build on them. Responsible science, on the other hand, refers to being reliable, ethical, and secure, respecting privacy, research integrity, and national interests. So this is something that we really need to combine and look at the same time. The Ministerial Committee on Science and Innovation has highlighted the need for national guidelines that help institutions put open and responsible science into practice. And fair data is just one of the practical tools to achieve open and responsible science at the same time. And I think it is worthwhile to remind us what FAIR stands for. We're always talking about it, but sometimes we forget a little bit what it means. Findable means that data is not hidden in a drawer. People and machines can actually discover it. Each data set needs to have a unique persistent identifier, like a DOI number, something like that, so it can be clearly cited and located. It is described with rich metadata, clear information about what the data is, how and when it was collected, and by whom. The data and the metadata are stored in a searchable repository, so when someone looks for the relevant data, it shows up. When we are talking about accessible does not mean that everything is fully open to everyone. It means that there is a clear and reliable way to get to the data. Access uses standard and open protocols, typically via the web or APIs, so no special or proprietary tools are required. Where needed, login and permissions can control who can see sensitive data, but the metadata remains visible, so people know the data exists. In practice, this means that when someone finds your dataset, they don't hit a dead end. They know how to request or obtain the data. And then, if we come to the I, the interoperability, it means that the data can work together with other data and systems. It uses standard formats and common vocabularies. It uses a shared language, so different tools and databases understand it. It includes links to related datasets and resources, so data is connected rather than isolated. And this reduces the time researchers spend on cleaning and converting data and makes it much easier to do combined analysis across projects, institutions, and countries. And finally, reusable means that someone who was not part of the original project can understand, trust, and legally reuse the data. There is clear documentation about how the data was collected and processed, and what its limitations are. A transparent license states what others are allowed to do, for example, reuse, modify, or use commercially with proper citation. Data follows community standards in the relevant field, so it fits into existing tools and workflows and remains valuable over time. To sum up, the 10-year policy aims for a strong, collaborative, and innovative research system that benefits society and the environment. Open and responsible science, and especially fair data, are central to turning public investment in research into long-lasting value. By making findable, accessible, interoperable, and reusable data, we enable better collaboration, stronger evidence for policy, and more innovation. We know that Icelandic data are a long way from being fully fair. So there's work to do. That work will require clear policies, shared infrastructures, and practical support for researchers and institutions, but it will pay off in better science and better decisions for society. I hope this was philosophical enough for us to talk about later, but thank you very much.
Yes, I was going to talk about the EPOS and the roadmaps, the European roadmap and the Icelandic roadmap. And we are focused on this one project here, EPOS, and it's a collaborative project, and the institutions that are participating in it are shown here. It's led by the IMO, also with participation by the university, the Institute of Natural Science. It used to be two separate institutions, and Landmælingar also, but they joined, and so both of them are in here, and ISOR, the Icelandic Geosurvey. Like I said, this has been funded through the S3 roadmap by the EU, but also recently through the Icelandic Infrastructure Fund. So EPOS stands for the European Plate Observing System. It has a really long timeline, going back to even before 2008, and it is a European collaboration on construction and harmonization of electronic infrastructure to provide open, fair access to multidisciplinary earth science data. And since 2008, EPOS has been funded on the roadmap for the S3 roadmap, the European Strategic Framework for Research Infrastructure. In 2008, after many, many years of constructing this electronic infrastructure, the EPOS-ERIC, the European Research Infrastructure Consortium, was established formally, and we've been members. Iceland has been member since the beginning, and today there are 20 European nations members of the organization. The ones that are members are shown in dark green. The ones that are red are still have not joined. Germany has taken a very long time. They're still observer, but they are required to become a paying member next year. Unfortunately, the UK is dropping out. They cannot manage paying their fee and their commitments. And I think this is an example of what happens in a consortium like this, where you have an infrastructure that you're building for a long time. If you don't maintain the group that is in the beginning, if they age out and new people come in and they don't know what it's about or what's important, things can just fall apart. And I think that may have been some of the reason why the UK is dropping out now, because they were one of the leaders in the beginning. And the same about Germany. They had a leader there, he fell ill, and then there was really nobody that stepped in. So for a long-term infrastructure like this, if you join such a project, then you need to think about, as you age, there need to be people who can step in, because this is a job that takes decades. So, and the reason Finland isn't in there is because I was told initially when they started, the person who got the email didn't respond. So for years it has taken them a long time to get on board, but they've been working towards it for a long time, and we had a collaborative Nordforsk project that the Finns were leading, so they are participating in the EPOS projects, but they have not formally joined, but they will be with us soon, I think. So why do we need EPOS? The European research organizations in Europe in solid earth science, they are widely distributed over the entire continent, and they are frequently disconnected. So the EPOS, the European Plate Observing System, is taking on the challenge to make their enormous wealth of scattered scientific data universally and openly accessible in order to foster state-of-the-art earth science research and innovation, and to address and solve scientific and socio-economic issues impacting the environmental footprint. And these two points are what the EU is interested in, to make European science more competitive internationally. They are funding these roadmaps and these roadmap projects and these infrastructure projects to build a stronger and more connected society, research society in Europe. And in particular, the goal, at least for the scientists, is to enable a better understanding of the physical processes controlling earthquakes, volcanic eruptions, tsunamis, as well as those driving tectonics and earth surface dynamics. And those, of course, lead to significant hazards near populated areas. And also to ensure long-term sustainable use and reuse of these multidisciplinary earth science data and products and services. The services are not just for data, they are for data products, services, and software, and integrate the diverse European research infrastructure under a common federated framework. And then also to establish a comprehensive multidisciplinary research platform for earth sciences in Europe. Here's the timeline of EPOS. This conception was sometime after the year 2000. Many people claim that they had the idea, but they're in different countries. At least I don't know who has had the idea. But anyway, this has been a long time coming. And in 2008, the EPOS project or idea went on the ESFRI roadmap. We've had these different phases of projects, preparatory phase, implementation phase, and then EPOS on, it should be somewhere here. So there have been one project after another. In 2018, ESFRI assigned EPOS a landmark status. And in 2018 also, the EPOS ERIC was formally established. We have been, like I said, participants in EPOS since the beginning of the preparatory phase with the first funded project in 2010. And these are the participating institutions that I mentioned earlier. The planning here in Iceland started very early on. I was on this committee to make, to project do research with other institutions to find out how should we reconstruct the infrastructure fund to make it more able to fund big projects and real infrastructures. And this was very informative, and I really enjoyed it. And out of this, we talked to many of the Scandinavians also. They gave us all kinds of advice. And I think the way the infrastructure fund is structured now is based on the best methodologies that we could find with the other Nordic countries. So I think we gained a lot from this this period. So when the first call came for the Icelandic to be on the Icelandic roadmap, we were ready to apply, and we got on the roadmap. So we are there since 2000, and we sent these yearly proposals to build up the EPOS services. The last proposal went in on Thursday, and so hopefully we will continue to get funding to continue this build-up. And this what I've been mentioning here is also displayed in this figure here. where I put all these different projects that fall under the SFRI umbrella, although this one probably should be down here, but it's in support of these SFRI projects. Here in the second box are research calls from the EU and projects that have been connected to EPOS and to the build-up of EPOS, and most of them would not have happened without this SFRI project being there. And then we started also nationally some years later. So there's been several EPOS projects, one following the other. From this initial one came the idea of calling for supersites. This was the year after Eyjafjallajökull eruption, and we decided, the Icelanders, to join forces. We didn't just join other proposals from other countries. We went on our own, and we managed to get the call. We won the call, and we got 5 million, 6 million from the EU, and there was much funding. But this had a huge impact for us to build infrastructure, for instance, in Vatnajökull, so that when Bárðarbunga started, all our infrastructure that came through the Future World project was already available to monitor seismicity and deformation at Bárðarbunga. There was also a similar call in the Southern Europe, but here there was a consultation call from the SFRI in 2012, and two of us who were in the Volcano Thematic Core Service of EPOS, we responded to this, and we sent in a proposal for why it was necessary to connect this fragmented community in volcanology in Europe, because the volcano monitoring institutions are a big part of this, and they are distributed all over Europe. They're like in the periphery of Europe. So when a few later we got favorable reviews, so we were of interest to the EU. So when the call came that was fitting for us to send in this proposal here, Eurovolc, which was led also from Iceland, we were probably a little bit prioritized, so we got this funded. And this has also meant a tremendous importance for us in the volcano community. And then there have been other projects that have been called, these are more research projects, digital twin projects, but they are connected to EPOS, so most of these would not have happened without it. Nationally, we started EPOS Iceland on the Icelandic roadmap. We've already gotten, this is an old slide, it's already up to 1.3 million euros that we have from the infrastructure fund, and the Italians and the French, I put it there because this was what I presented in this volcano group. They started a little bit later, but they are also funding nationally their build-up. So how is EPOS constructed? EPOS operates this multidisciplinary distributed research infrastructure that enables integrated use of data products, and facilities from the solid earth science communities in Europe. And the architecture has 5 main components, and 2 of them are highlighted here, this number 1 and 2. The first one, which is the foundation in the framework, and it's formed by these national research infrastructure funded by the countries themselves. So the most investment is in the countries, and then the EU or SFRI is bringing funds to create this electronic infrastructure to connect to these data storages. Yes, look, that's what I've been saying here. It's focused on reducing this fragmentation of the communities, integrating and harmonizing the data and products and making them openly accessible. And this is the data and product delivery framework, which is funded by the EU members of the EPOS ERIC. So to be a member of the EPOS ERIC, you have to pay a yearly fee, which is dependent on your GDP and some flat fee. And that falls under this green box here. Within this box, then, are these other items, the thematic core services, the integrated core service here, 4, and this box here, which is the EPOS ERIC, is the governance of that controls the integrated core services and interacts with the thematic core services and supports them, their operations, their services that we are providing. We get a little bit of funding through our contracts with the Volcano Thematic Core Service. So there are 10 community-specific entities in here with transnational governance focused on community-specific data and products, software and access to transnational and virtual access. So we have also, for instance, in Euroworld, we had 22 projects that we funded for transnational access for researchers all over Europe to apply for and go to these institutions to use the infrastructures there, the facilities and whatnot. So this is also part of it. The integrated core service, it's this innovative e-infrastructure that provides access catered to users through a common platform, the EPOS data platform, to the entities in the TCS portfolios. So you can enter these thematic services, you can do that, but everything is still centralized here. It's most convenient to enter here, and then you can connect to everything. And EPOS ERIC, I already explained what that was. So what does open access really mean for EPOS? It means access to standardized formats, like Guðni was saying, quality check data and metadata according to FAIR standards, development of interoperable services, otherwise you cannot run big data analysis without them being interoperable, and then you have to guarantee long-term access. And we have these contracts that were mentioned. In order for us to distribute data of our collaborators, we have to make contracts with them so that we are allowed to distribute the data, and they promise not to just disconnect from the services. So there are contracts back and forth between all the entities in this framework. So quality checking, it means that all the data and products and software, they have to be reviewed for quality, and their provenance and reliability of quality checking or processing is described in this quality assurance document. So all the services that are on the data platform, once they are fully ready, they are required to have such a quality assurance so that the user can go and look at how is this data made, how is it processed, how reliable it is. So the user has some idea of how good this data is for research. Because, for instance, the data we have in Iceland is mostly collected in these monitoring infrastructures. We have huge amounts of data, but there is almost no time for quality checking. So now when we are starting, there's a lot of work to quality check everything, the metadata, the data themselves, because they also have some data that is not checked. Am I going too long? Okay, all right. So all the metadata are required to be findable, requiring them to be standardized and keywords to be harmonized between the services so that we use same keywords. If you enter in one thematic service, you can find data in other thematic communities. Accessible means that the data and metadata are downloadable. Interoperable data and services require them to be standardized, the services themselves, that their keywords are harmonized across different disciplines, to allow processing them across disciplines. So I think this is almost done. This is our API. All our services that we have made in Iceland, they are, or most of them are on the API platform at the IMO. The access is here. This is the EPOS data platform access. We have 17 services available. You can enter through there, or you can go to the platform itself. This is the front page of the platform. These are the different thematic core services. We are mostly working in this one, and we get most of our funding through connection with the volcano community. We submit seismological data to the seismology TCS, and the Náttúrufræðistofnun, they are sending their geological maps. They're already sharing geological maps through the geological TCS. We have installed a standardized GPS service. We've been sharing our GPS data through a service that we created ourselves. But there is a standardized service called GLASS, and we installed it this year. It will become operational in 1 or 2 weeks. And by that time, then our GNSS service will be standardized, and we will start sharing our data through this node. In the future, we will also implement a national node for seismology that will be connected to the center in Europe. So we are starting to focus on these big data sets to create standard services to them and make sure that all the data is also in standard format. So here are just examples of some of the services. These are some of the largest earthquakes we've had. These are shake maps. They show how much the surface shook. These are automatically generated, and they are then available. If you go to the platform, you can download these. These are borehole. These are metadata about borehole cores from the Náttúrufræðistofnun. These are volcano images from the university. They've spent a lot of time taking pictures of all eruptions in Iceland for like 20 years or 30 years. So these are being made available there, as well as hazard maps of ashfall and products related to those to make them useful. And finally, this is the access to the different platforms and a picture of the Eurovolt group at our kickoff meeting, which we held in Reykjanes Peninsula because it was middle of winter and it was the only safe place to be sure that people could get from the airport to the meeting and back to the airport. And then it turned out to be really fortunate because only 4 years later, the eruption started on Reykjanes Peninsula. So we had marched with all these volcanologists through all the areas near Eldvörp some years before. So it was, we were really happy there. But yes, thank you.